Hello everyone. So in the previous video, we saw a basic introduction to two-dimensional arrays. What does it mean logically and how do you store it, how do you create it, etc. Now let's take a look at a bigger program which will multiply two matrices, matrix multiplication. Okay. Now the main thing over here is systematically, whenever you are taking any array or any matrix as input, you will systematically define, let's say in case of matrix, you will first define the variables rows and columns. Then you have to ask the user how many rows and columns. How many rows and columns. Okay. And then, uh, okay, how many rows and columns. And then we'll take that as input. Rows, columns. Now this is, we now know how many rows and columns are there. Then you will actually allocate space for the matrix in this way, rows and columns. Okay. Now, because we are doing matrix multiplication, we will have to do this for, there is one more step in input. So let's complete that, and then I will tell you what the point I'm trying to make. Okay. So always remember that outer loop will iterate over the rows and inner loop will iterate over the columns. Outer loop for rows, that is the elements. So rows are like how many arrays are there within the 2D array, and columns are like what is the size of each of those arrays. Okay, so int j equal to 0, j less than columns, j plus plus. You will simply take the elements as input. Now to guide the user, what you can do is you can add some custom cout messages, right? So for example, you can say cout, this is row I plus 1, because in real life we don't start the counting from 0, so we are adding 1. So therefore the first row will not be row 0, it will be row 1, then row 2, and so on. Okay. And after taking the entire row as input, then it will go ahead and keep on. So slight help for the user. Now the same steps have to be performed for the second matrix as well. So you will say rows 2, let's say columns 2 for matrix 2. Okay. Now did you see what I did just now? I just copy pasted the code. Okay. I saved my time in typing the code. I know that something works, so I replicated it. But this is not the elegant or the right way to do this. So instead of doing it this way, what we could have done is we could have defined a method called as void matrix input. Let's say we'll give it some name, let's say matrix input, and it takes int matrix. Now here's the interesting part. When you're passing a matrix to a function, it has to specify, like you have to specify the number of columns. Okay, and I hope you understand the logic behind it because of our discussion in the previous video. Now we'll assume that our matrices will have no more than 10 columns, 10 is a sufficiently large matrix for us. So we'll say that second dimension will always be 10. First dimension we are leaving free to our choice. Okay. And option, so additionally we can also pass rows and columns. So this is my prototype. Okay. Now let's first run this code just for you to understand how this works. Now just like we take the matrix as input, we can also print the matrix, right? So this same for loop. Again, see, I'm copy pasting the same thing, right? And I'm trying to make a point. Okay. See out matrix 1 is, and then this entire matrix. And similarly, so instead of C in, you will write C out and change the operator. Okay. And now matrix 2 is has rows 2, right? Matrix 2 has rows 2, columns 2. This is matrix 2. Got it? Should work. Let's run it. So how many rows and columns? Let's say for simplicity 2 by 2 का लेते हैं. So the first row is, let's say, 1 2. Second row is, let's say, 3 4. And for the second matrix now, it is also 2 2, let's say 2 by 2. First row is, let's say, 3 4, and second row is, let's say, 5 6. Got it? So matrix 1 is, now because I did not use any tabs or new lines, this is getting printed in a really ugly way. Say I use backslash t over here. Better. Oh, I did not take the matrix. Okay, forgot to change it over here. Okay, so let's run this again. Okay, so row 1 is this, row 2 is this, matrix 2 is row 1 and row 2. This is done. I know this could have been displayed in a better way. Yeah, I could just add a backslash n over here. That will increase the clarity a lot. Okay. But I hope you get the point. Now, as you can see, a lot of code is repeated again and again. So now we will see that how we can do the same thing and how we can reduce the number of lines of code that we type. Okay, 8 and 9, let's say. So matrix 1 is row 1 is 1 2, row 2 is 3 4. Matrix 2 is row 1 is 1 2, row 2 is 8 9. Okay. Now the same thing that I'm doing here, let's say I will just create another file. So, or you can say that, fine, you can. So is this code modular? Though this is a non-modular example of a code. Basically, as you can see, the same code is getting repeated multiple times. Now, how many rows and columns in matrix 1 and in matrix 2 is a valid question that cannot be eliminated. Okay, but after we do this and we allocate the matrix, this particular part can definitely be done only once. So this is redundant for sure. So this thing we will put inside. I will write the function here itself instead of prototype. This thing I will put inside the matrix input. Simple change. And now here itself I'll call the function matrix input matrix comma rows comma columns. Simple. Now the thing is, because here we have mentioned that the number of columns is 10. This is the maximum limit that we have statically allocated. When we are passing this particular matrix, it will expect this value again to be 10. We still have flexibility in rows, no doubt. And we also need to take the value of columns from the user. So it's like you're allocating 10 columns, a space. Actual space used will depend. It may be a 2 by 2 matrix or 2 by 3 matrix. So only 2 or 3 columns may be used out of 10. Got it? So similarly over here, this entire loop, this can be replaced by one single function call is matrix input. Got it? So let's say 2 by 2 again. Okay, again I made some mistake. Possibly I did not pass that matrix. Right? So I now pass the matrix, and here also I have to make the same change. When I'm declaring it, I have to declare it 10. Why? Because in this function header I have written 10. In this function header I write 5, then I will pass 5 over here. So for example, if I say 5 over here, then here also I have to match that. Okay, this problem can be solved. So right now the number of rows is still dynamic, but number of columns is fixed. And to make both of them dynamic, we'll have to go for vectors, which is beyond the scope of the current video. Here we are only studying the basics of multidimensional arrays. Right? Perfect. Now similarly, as you can see, I can also create another method for matrix output, right? Almost the same logic, but now instead of cin, we will have cout. So cout matrix ij, right? Apart from that, I don't think there is any other change. Of course, to make it neat and clean, you will use backslash t over here. Then here you will use backslash n. Okay. So now here what we will do is we'll call the matrix output function. So let's name this function as matrix output. Okay, let's name this as matrix output. So here you will simply call matrix output, matrix comma rows comma columns. Simple enough. And now similarly you will do it for this code, right? So this entire thing you will replace by just a call to matrix output, matrix 2, because it has rows 2 and columns 2. Got it? And now let's again run this one by two. Let's say matrix has only one row. Let's say 3 4, and this is also fine, 3 4. So matrix 1 only has one row with two columns, matrix 2 also has only one row with two columns. This works. So now you can say that yes, the program is modular. The program is definitely modular. Okay, now let's talk about matrix multiplication. We'll continue with this program but in the next video.